What if there are other universes just like ours, with an infinite number of Earths, with uncountable versions of you? And what if we don't have to look too far to find them? Maybe a mirror version of our reality is right here. This is What If, and here's what would happen if we could open a portal to a parallel universe. Our universe began when a small but very hot singularity exploded in the Big Bang 13.7 billion years ago. But maybe it wasn't the only one to be born then. In physics, space and time fuse into one four-dimensional continuum, space-time. If this space-time is flat and stretches far beyond the limits of our observation, there is a possibility that it holds uncountable, disconnected universes. But for all we know, there are a limited number of ways the particles in those other universes can be put together. At some point, the realities will have to start repeating themselves. That means, in theory, our reality is only a small part of what's out there. And someone just like you might be living in a parallel universe similar to our own. And that universe may be as close as 1,000,000 trillion trillionth of a centimeter away. Although the wall between the universes might be incredibly small, traveling between them won't be easy, but it could be done. All you'd need is an 85 megawatt nuclear reactor capable of firing billions of neutrons on command. That's how a team of physicists working in Tennessee's Oak Ridge Laboratory are trying to open the gates of a mirror universe. Of course, they have to find it first. It all comes from a theory that says, if you beam neutrons at a wall, none should pass through. If some do manage to make it to the other side, it would mean that they've transformed into mirror images of themselves as they went through the wall between the two worlds. How do we even know all that? Well, there's one odd thing about neutrons. In particle beams, on average, they last for 14 minutes and 48 seconds before they decay into protons. But if you place neutrons in a lab bottle, they'll break down 10 seconds faster. It's not something we can explain with physics yet. Neutrons are all the same, and there shouldn't be any 10-second difference in their lifespan, regardless of where they're stored. Could it be possible that the neutron experiments didn't go as expected because physicists accidentally opened a portal to a mirror world? That would be the first evidence that a mirror universe exists right next to our own. A mirror world with mirror atoms. Maybe even a mirror Earth. An entire mirror world, almost totally cut off from ours. Could you meet another version of yourself in that mirror world? Now, it gets a little complicated. Even though particle configurations can repeat themselves, the odds of finding a portal to a parallel universe that's exactly the same as ours are close to zero. Think about it. There are a novum vigintillion particles in the universe. That's the number 1 followed by 90 zeros. Every single one of them would need to have had the same interactions for 13.7 billion years to create an identical universe to what we have now. The mirror universe would most likely have its own mirror laws of physics, but it's hard to know for sure because nobody has detected a single mirror particle yet. Maybe we shouldn't be searching for answers in a lab. Perhaps we should be looking in space itself. Our universe is full of dark matter. We can't observe it directly, and we have no idea what it's made of or how it works, but we know that dark matter is strong enough to stop galaxies from flying apart. Yet, we can't find it. Perhaps the reason is that dark matter is leaking from the mirror world into ours. If we could detect that, it would confirm that a mirror universe exists. Because we know that there's 5 times more dark matter than there is visible matter in the universe, you've got to think that a mirror universe is much more massive than the one we live in. Even if we did manage to open up a gate into another world, the portal would be incredibly small, Too small for you to see anything without some very powerful lab equipment. We'd still be dealing with neutrons and protons, remember? You could only enter that realm if you had the ability to shrink yourself to the size of an atom. But that's a story for another What If.